This is the notes for Unit 1, 3.2 and 3.3, multiplying and dividing rational numbers. Our idea is multiplication is repeated addition. So if I have 8 jumps of -6, 8 times 6 would go 6, 12, 18, 24, 30, 36, 42, 48. So I can repeatedly add, or hopefully we've memorized 8 times 6 is 48. There's going to be a slight difference though here when it's positive or negative numbers, okay? So if I have, for example, 4 times 10 is 40, well, what about negatives and negatives? Okay, so let's start with an analogy here. If I love to love you, then I love you. So a positive and a positive will stay positive, okay? But what happens if I love to hate you? Well, darn it, then I hate you. If I have a positive times a negative, I'm going to end up with a negative. If I hate to love you, I do not love you, then I, again, hate you. A negative times a positive is a negative. Or if I hate to hate you, then I love you. It's the idea of a negative times a negative. It's like the opposite of the opposite. I get back to my positive, which is my love. Okay. Another one you might have seen, slide down here a little bit so you got some room, is what I call the Dr. MD triangle. So for multiply and divide, it'll always have a negative and a negative with a positive. Okay. So if I have a negative times a negative, I cover up my negative, and I would get a positive. If I have a positive and a negative, I cover up a positive and a negative, and I'm left with a negative. If it's a negative and a positive, again, it doesn't matter which one. If I cover up one negative and a positive, then he is going to be negative. Okay. Any way you want to use it, you totally can. If you like the analogy, if you like the multiplication triangle, if you have another analogy that works, that sounds great to me. Let's start with then -7 times 2. 7 times 2 is 14. Then are they the same signs or different signs? A negative and a positive would then be a negative. They were different signs. So if I hate to love you, then I hate you. I'd get -14. You could also think of it as 2 people owe me $7. So altogether, they owe 14 bucks. What about 40 divided by -8? Well, 40 divided by 8 is 5. I had a positive 40 and a -8. So I should end up with a negative for my 5. Okay. They have different signs. So if I have $40 split up among 8 people that I owe debt to, each of them are going to get 5. A positive divided by a negative will end up with being a negative. I love to hate you. All right, where it gets a little tricky is with our rational numbers. Remember, the definition of rational is that it can be a fraction or a decimal, not necessarily just a whole number. An integer is a whole number. When it's a fraction, I'm going to multiply straight across. No need to make a common denominator here. I'm taking a part times a part. So I like to think of it as one big fraction. On the top, I have 3 times 4, which is 12. On the bottom, I have 8 times 5, which is 40. Okay. But again, ask yourself, positive or negative? I have a negative and a positive. I love to hate you. I should have a negative. Okay. If you'd like, you can also simplify this. So 12 and 40, I could divide both by 2. I would get -6 over 20. I could also divide it by 2 again and get a final answer of 3 over 10. Okay. Before you even multiply, another option would be you can simplify here. So there's this fancy word called a commutative property that you can flip these. So 3 over 8 is the same as, times 4/5 is the same as 3/5 times 4/8. Notice how it's still 3 times 4 is 12, and 5 times 8 is 40. Well, what can I do with 4 and 8? Divide them both by 4. Just makes life a little easier. Before you multiply across, if you want, you can simplify those diagonals, just like how if it was a fraction, you can simplify them on the top. So 3 times 1 is 3. 5 times 2 is 10. A positive times a negative is a negative. All right, let's try another one. We got 2.5 times 4. When I added or subtracted decimals, I had to line up their decimal place. Not so with multiply. I'm going to go ahead and put 25 on top, 4 on the bottom. Ignore that decimal place for now, okay? Think of it like 25 times 4. 4 times 5 is 20. 4 times 2 is 8, plus 2 would be 10. Okay, then I got 2 follow-up questions this time. 1, positive or negative, just like last time. I have a positive 2 and a negative 4. A negative times a positive. I love to hate you. I should get a negative. But then the other question this time is, where does my decimal go? And the original one, I had 1 decimal place. So in my final answer, I'm going to do the same thing. 1 decimal place for an answer of negative 10. If I have $2.50 times 4, I should end up with $10. When I multiply them, treat it just like 25 times 4. But when you get done, that's when I look to that decimal. I'm moving 1 place, so my final answer moved 1 place in that same direction. Okay. All right, now let's go back to our fraction. Again, no common denominators here. When it's a fraction, what I need to do, though, is make them improper. 3 times 5 is 15, plus 2 is 17. Okay, so right now I have a fraction times a fraction, a whole number times a whole number, and all the combinations there in between. So instead of worrying about trying to do the fractions and the different pieces together, I make them improper. 3 groups of 5 would make 15 slices of pizza plus the 2. Over here I have a whole pizza, so 3 plus 1 would be 3 slices plus my 1. No need to make common denominators, but if there is a whole number, I'm going to turn them into 1 fraction. 4 over 3, because I did 3 times 1 plus 1. Okay. Now let's multiply across. 17 times 4, 8, carry the 2, would be 68. Over 5 times 3 is 15. Okay. But our follow-up questions, is it positive or negative? And then can I simplify it? Well, this time it was a negative times a negative. Negative times a negative is a positive. And then how many times can 15 go into 60? 15, 30, 45, 60 would be 4 times. 60 minus 68 would leave me with 8 left over. Okay. All right, and our last one. I have 1.5 divided by 0.3. When I divide, you can think of that one like a fraction. Again, those decimal places move together. So when I multiplied, I went 1 place to the left. I can do the same thing here. If I took this times 10, the decimal would go 1 place to the right. Same thing here. I take him times 10, he goes 1 place to the right. So instead of thinking it like 1.5 divided by 0.3, I'm going to do 15 divided by 3. Didn't that make him a little bit easier? 15 divided by 3 is 5. And we lucked out. There was no positive or negative to worry about here. They were both positive, so my final answer would just be 5. Okay. So again, let's look at one more time from the top. Your final step will always be, is it positive or negative? If you negative times negative, hate to hate someone, then it'll be a positive. If they are different signs, though, a positive and a negative will give you a negative. Doesn't matter which one you cover up, or if you go this way, a positive and negative will give you a negative. Where you got to be careful today, our rationals are fractions and decimals. When it's a fraction, my goal is to go straight across. If I have a whole number, It messes that up, and now I can't go straight across, so I have to make him improper first. I do the bottom times the side. My whole pizza gets cut up into slices, plus what you had on top. If it's a decimal, then the decimals move together. If he had 1 decimal, my final answer moved 1 to the left when I multiplied. When it was division, I wanted him to go to the right to be a whole number, so the same thing happened with the number I was dividing him by.